Okay, so in this video we're going to be discussing the sector and arc length of a circle. Now, before we fully go into what a sector and arc length are, the first thing I'm going to do is just give you a quick reminder of what we already know about circles. So we know you can have an area and you know you can have a circumference. A sector is more or less a slice of pizza, so it's a part of an area, and the arc length would be how much crust is on that slice of pizza, so it would be the outside, so that kind of part of the circumference. So area is this side, but a sector is a smaller part of the whole area. An area is a sector is an area itself, but it's only a part of a full circle. The circumference is the whole outside of the circle, but an arc length, as you can see here in this picture, it's only a small part. So it's from this point all the way around to that point. So arc length is actually a subsection of circumference. Now, the first thing I'm going to do is just write down the formula for the area of a circle. And we know that's pi r squared, and a circumference is 2 pi r. That's simple enough. That would be in your log tables. But for the sector, it's only going to be a part of that. Okay, so a sector is this blue section here. So we want to find out what part of that whole circle is taken up by that sector. Okay, now another little thing I'm just going to introduce at the start. We have two different ways of measuring degrees. Measuring angles. You have degrees and you have radians. So degrees, the most degrees you can have in a circle is 360, and in terms of radians it is 2 pi. So that's our two measurements for an entire circle. A sector is part of this circle. So what we're going to do is combine the fraction of the circle that we're using with the full formula for the area. So a sector is the area formula, pi r squared, but it's only a fraction of it. Now, if this angle was 50 degrees, it would be 50 out of 360. If it was 100 degrees, it would be 100 out of 360. If it's 270, 270 out of 360. So what we're going to do here, it's pi r squared for the area, but it's the fraction, so if whatever that angle that is, over 360. So it's theta over 360. Okay? Now, if your measurement is in radians, it's slightly different. So it's going to be the similar setup, pi r squared, but it's going to be the degrees in radians divided by 2 pi. So they're the two formulas that you use for the area of a sector. Whichever one you're using. If it's degrees, you use this one. If it's radians, you use that one. Now, it's almost identical with the circumference. Okay? So an arc length is only part of the circle. So if it was the circumference, it would be the whole way around. But because it's an arc length, it's only part of it. It's from here to there. So we're going to use the 2 pi r formula. But again, you use the fraction of the circle that is included. So if it's degrees, it's theta over 360. Almost identical to above, apart from you're using the area, instead you're using the circumference. If it's in radians, you can almost get it. 2 pi r theta over 2 pi. So there are your two formulas that work. Okay, so in a second I'm going to do a quick example of how to use these formulas in a question. Okay, so this example is going to have several different parts. So I'll just read through it first, explain the diagram, and then we'll go through each individual question. So, a man wants to make a pond and a flower bed in a right-angled corner of his garden. He wants to put a small fence on the arc of both the flower bed and the pond. Okay. Okay, so it says in the question it's a right angled corner. So it's a right angle here. We have a pond and we have where the flowers are going to go. Now on top we have radius 1 for the circle, or for the pond, and the flower bed length is going to be 2 meters from here to here. So I'll just have a quick read through of the whole question again, or the whole information again. He wants to make a pond and a flower bed in a right angled corner of his garden. He wants to put a small fence on the arc of both the flower bed and the pond. So that means this section here and this section here will have some form of a tiny little fence, I suppose, to keep animals out of the pond and out of the flowers. So the first question says, what area will the whole project take up? So we want to find the area that the flowers and the pond take up together. Now it's not a full circle, it's only a sector of a circle, and we want the area, so we need to find the area of a sector. Now the formula for that, F for formula, the formula for the area of a sector is pi r squared theta over 360. Okay, now what is the angle involved here? It's 90 degrees because we can see it. It says in the question it's right angled. I've also the diagram put in. So what I'm going to do is fill the numbers into the formula. Pi is just pi, that's grand. The radius of the whole sector is 1 meter here and 2 meters there. So the whole radius is 3 squared. Theta is going to be 90 degrees over 360. And I can slowly work down through that. Pi stays as it is. 3 squared is 9. 90 over 360 is 1 over 4. So my answer will be 9 over 4 pi. Or if you want it in decimals, you can use your calculator. 9 over 4 multiplied by pi. That gives me roughly 7.068. So 7.07 is approximately 7.07 meters squared. That's the total area that will be taken up by the flower bed and the pond. Now the second question, what area is taken up by the flowers only? So if we look back to the diagram, you can see that the flowers only take up this red section. It's not the whole sector, it's just this red bit. So what we need to try and do, if we can find the area of the pond itself and then remove it from the total, that's where we'll get our answer from. Okay, so I'm going to try and find the area of the sector of the pond first. So the area of the pond, you see that? Yep. Area of the pond is same formula, pi r squared by 1 over 4. In this case, r is only 1. So we pi by 1 by a quarter, which is 1/4 pi. Now, you'll see why I left the answer in pi up here, because we're going to try and work it out. We're looking for just the flowers. If I can take away the pond section, that will give me the remaining flower section. So the area of the flowers is the total area, take away the pond. Now the total area was 9 over 4 pi. So we have 9 over 4 pi, take away 1/4 pi, or 1 over 4 pi. So that leaves us with 8 over 4 pi. 8 over 4 is just 2. So the area of the flowers is just 2 pi. And if you want, in the exam, they might say round that to 2 decimal places or give it to the nearest whole number. That's when you use your calculator. But when I'm working with pi and I know it's going to cancel later on or work together to make it a bit easier, I'd always leave it there and then convert the answer at the end. Now, so the final question says, how much fence is needed? Now, if we look back to the question, it says he wants to put a small fence on the arc of both the flower bed and the pond. So we need to find this red bit here and this red, you can't really see it because of the colour, but that bit here. So it's an arc length formula we need to use. Now the arc length formula is 2 pi r times theta over 360. It's the angle of the inside of the circle, of the arc, sorry. So I'm going to try and find this arc length and this one. Now I'm going to find the pond first because it's a bit easier. So the pond would be 2 times pi times 1, because the radius is 1, multiplied again by 90 over 360. So we have 2 pi by 1 by a quarter, which is the same as pi over 2. So that's the arc length of the pond. So I'll put a box on that so it stands out. Now, if we look at the fence, the fence of the flowers. It's all of this section here. Now in the last part we only used the 2 meter part to try and work it out, and the 1, but now this arc length is actually 3 meters long. So we need to be careful with that. So again, it's the same formula as on the left hand side. 2 pi, the radius is going to be 3 this time, multiplied by, again, 90 over 360. And as I've said earlier on in the video, if it was radians, you just put in the radian degrees. So it's more or less the same thing. Or sorry, the radian measure. So 2 by 3 by pi is 6 pi, multiplied by a quarter. And that gives me 6 over 4 pi, which is the same as 3 over 2 pi. So the length of the pond fence would be 2 pi meters. Sorry, I forgot the units. And the flower beds one would be 3 over 2 pi meters. But we want it combined. So it's just this one and this one. So you add them together. 3 over 2 pi plus 1 pi over 2. That's the same as 4 over 2 pi, which is just 2 pi meters. And there's my final answer.